All right, laws of exponents, quotient rule. When dividing with bases that are the same, you subtract the exponents. Subtract either on the numerator or on the denominator with the higher amount. So what they mean is, on here, if I've got x to the fifth over x to the third, I'm going to take x to the 5 minus 3, and we get x squared. The reason this works is if we expand x to the fifth and x to the third, it would look like this, and an x on the top and an x on the bottom would cancel, and you're left with just x times x, which is x squared. On this next one, if we think of it that way, a times a over a times a times a, these would cancel and just leave 1 on the top, and I'd end up with 1 over a. You could think of it as 1 over a to the first. So essentially we're taking 3 minus 2, but we're leaving that 1 in the denominator instead. So there's my answer, and there's my answer. So let's look at some more examples. So on number 1, I'm going to take 7 minus 3 and get x to the fourth. On number 2, I'm going to take 19 minus 11. I get y to the eighth. On number 3, we start with just 6 over 2. Normal fraction would reduce to 3 over 1. And then I take 8 minus 1. That m would be m to the first. So I'm going to have 3m to the seventh, and then everything else would be gone. So if you cancel this 1m with one of these up here, you can think of it that way. And then there's just 1 left in the denominator, so we can leave that out. On number 4, this would be a to the first, so 5 minus 1 is going to give me a to the fourth. 4 minus 2 is going to give me b squared. On number 5, 10 minus 6 is going to give me m to the fourth. This would be 4 minus 1, so we get n to the third. And then down here, 24 over 6 reduces to 4 over 1. And then the k to the fourth would cancel 4 of these and make that 3. And 6, the t to the 6's are just going to go away. So I'm going to be left with 4k to the third on the top, nothing left on the bottom. Now, if we skip over to the other page, I'm going to do just a few of these. So go down to number 3. We want to look at something that's a little different. So 6 over 9, regular fraction, divide by 3. So that gives me 2. Divide by 3 gives me 3. And then I have m to the fourth on top and m to the 12th on the bottom. So this m to the fourth is going to cancel out 4 of these. 12 minus 4 is 8. So I have 2 on the top and 3m to the 8th on the bottom. So because there were more m's on the bottom, that's where that answer is going to go. So you can think of it as 12 minus 4 is 8, but that ends up in the denominator. And then if we go to number 4, this x to the third is going to cancel 3 of these, makes that 5. And then 12 minus 9 is 3, so those 9 are going to go away, cancel 9 of those. I'm going to get x to the fifth on the top, y to the third on the bottom. And this works because of, if you write them out and expand them, you are canceling. Okay, and then we'll skip to number 6. 8 over 10, if I divide by 2, it's going to give me 4 over 5. So I know I'm going to have 4 on the top, 5 on the bottom. And then I've got w to the seventh down here. 7 minus 4 is 3. So I'm going to have w to the third in the bottom. This is x to the first. 3 minus 1 is 2. So wherever that power was bigger, that's where your answer is going to go. Or you can think of it as 4 of these are canceling 4 of those, leaving 3. This one's going to cancel 1 of these, leaving 2. And there's your final answer.